Hello and welcome to Introduction to WebSockets. If you've been getting into web development, you've probably heard of WebSockets. And if you haven't used them before, you're probably wondering what they are and what they can do for you. Well, it turns out they're pretty cool and they can do a lot for you. This video is going to give you a broad introduction to what they are, when to use them, when not to use them. And we're not going to do any coding in this video. We're just going to talk about WebSockets so that you have a good understanding of what they are. And I bet by the end of watching this video, you'll be excited to learn more and to use them in your web apps. So let's jump into it. Okay, so the question that's burning in your head, what is a WebSocket? Let's look at a short definition. A WebSocket is a protocol that enables two-way real-time communication between a client, like a web browser, and a server over a single long-lived connection. This allows for instant data exchange without the need for repeatedly opening and closing connections. So there's a lot of key points there in that definition, but it still might not be clear exactly how this is different from what you've already been doing, like with regular HTTP requests. So let's go over that. Let's go over some key points about WebSockets. First key point, which was mentioned in that definition, is that a WebSocket is a persistent connection between client and server. This differs from an HTTP request. When you make an HTTP request either to load a web page or to make a request to an API, a connection is opened, there is an exchange between the client and server, and then that connection is closed. And oftentimes, during the course of you interacting with a web page, there will be several, if not very many, HTTP requests. A WebSocket is a persistent connection. It's a long-lived connection that stays open. Another key point about this connection is that it's a two-way communication between the client and the server. That's also in contrast to an HTTP request. You may think, but when I make an HTTP request, I make a request to the server, it gives me a response. Is that not two-way communication? In a sense, I guess it is, but the key here is that in HTTP, this interaction is always initiated by the client. With a WebSocket connection, it can be initiated by either the client or the server. That's a very key distinction. The fact that the server can initiate a communication with the client. Low latency is another aspect of a WebSocket connection. Latency, if you're not familiar with the term, refers to delay time. And since that's lower, that's a good thing. Once the WebSocket connection is established, the time it takes for an event to be sent to the server or from the server to the client is lower than that of an HTTP request because it doesn't have to open a new connection. There are fewer headers and it doesn't have to close the connection each time. So there's less work being done per request, perhaps, once the WebSocket connection is established. WebSockets are supported by modern browsers. There's no issues there. They've been around in modern browsers for over a decade, and you don't have to worry about compatibility with any modern browsers because they're extremely common and standard at this point. And also, thankfully, there are a lot of third-party libraries that make developing WebSocket logic much easier than it would be if you were using what's called the raw WebSocket API. So when do we use WebSockets? What kind of apps necessitate WebSockets? Let's have a look. Real-time updates. So any kind of app that involves having real-time updates without the user having to explicitly request for those updates. For example, a social media dashboard, a stock market ticker, or sports scores. So in those examples, you have your web page or your app open and things are changing on the screen without you, the user, or the client having to do anything. What's happening is the server is initiating communication and sending data updates. And then your client, your browser, is processing those and updating what you see on the screen. For example, when you get a friend request, you might just get a badge that pops up. or the stock market price is changing and that's reflecting on your screen. And of course, if your sports team is making an amazing comeback, you're going to want to see those updates in real time without having to keep refreshing your browser. Online multiplayer gaming. It would be pretty difficult to develop an online multiplayer game without WebSockets. In order to do so, you would have to query for information constantly. You'd have to keep checking, is it my turn? Whose turn is it? Et cetera, et cetera. With WebSockets, you can just write the logic to initiate that information update from the server. If another player makes a move, they send a socket message to the server, and then that server will send a socket message to whoever needs to receive it, such as me, and it shows me that it's my turn. I don't have to do anything. I don't have to keep querying for the latest state of the game. WebSockets are great for that. Chat applications, of course. When you have a chat application, you want the messages to show up right away. You don't want to have to reload. Collaborative tools. For example, Google Slides, where I'm showing you this little slide deck. If you've ever collaborated on any Google slide with someone, you see that those updates that the other person is making are showing in real time. It's very cool. But there are some disadvantages to WebSockets. Let's have a look at what those might be. You don't want to use WebSockets for everything. One disadvantage is that they have higher resource consumption, i.e. CPU, memory, that kind of thing. To maintain a steady and persistent connection like that does take some resources, more than an HTTP connection would. There are security concerns with WebSockets. You don't want to use WebSockets for sensitive information like authentication or anything sensitive. You basically only want to use them when it's necessary. They're not ideal for API interactions. You still want to use your HTTP requests to perform your CRUD operations and whatnot with your API. The reasons for this would be that you have like a RESTful API that adheres to a certain standard, a certain convention. That convention makes sense. With a socket system, you would sort of be inventing your own convention, and it wouldn't adhere to any normal standards. It would be difficult to document your API if you were setting it up to use sockets. It just wouldn't make sense. There are scalability issues with sockets. It can be difficult to scale an app that is using socket connections heavily because you're dealing with sticky server sessions, server sessions that the client needs to be connected to a specific instance of a server. And so it would be difficult to perform load balancing in real time, an issue I have not dealt with myself. Error handling, like when you're requesting an API or trying to load a web page, traditional HTTP requests give you these nice status codes. There's a lot of built-in features for handling errors when you're trying to get data or get a web page. This isn't the case with socket connections. Basically, all of the error handling is implemented by the programmer. So, when do we use regular HTTP requests? Quite a lot. We use it for any kind of basic data retrieval, like just the web page itself with the HTML, CSS, and JS. We use it for our authentication. Like I mentioned earlier, you don't want to use sockets for authentication. You still want to use good old-fashioned HTTP requests. It's much more secure, and it makes a lot more sense because there's no need to keep a connection open constantly for the sake of authentication. And also, as I mentioned earlier, CRUD operations in your RESTful APIs or your GraphQL APIs, you want to keep using HTTP requests just as you've probably already learned how to do, which is nice because it would be a shame if you had to throw away all those skills that you've already learned. File downloads. WebSocket connections are not necessary for file downloads. A simple HTTP request will do just fine. That HTTP connection will stay open for the duration of the file download, but then it'll be closed once the download is complete. And frankly, HTTP is a more suitable protocol for file downloads. Basically, if you're building any app where live updates are not needed, you most likely won't need to use WebSockets at all. So just for a visual aid, let's go over what the HTTP request lifecycle looks like, and then we'll go over what the WebSocket lifecycle looks like, and you can get a nice comparison between the two. So with an HTTP request, you have your client, your computer or your phone, and the browser within, and you have your server. And as mentioned earlier, the process is initiated by the client. The client looks up the server. If the server is there and running, it will create a connection. And then it will send the HTTP request with the headers and the method and potentially a body, a payload. And then the server will process that, do whatever it needs to do with it, and it will issue a response with a status code and also with a payload potentially. And then the client will receive that response and do what it needs to do with it. And then that connection will be closed. And that will repeat, whenever a request is made. So in contrast, the WebSocket lifecycle looks a little different. Let's have a look at that. Again, of course, you have your client and your server. And again, actually, the process is initiated by the client because the process actually begins with an HTTP request. When you enter your app, or actually probably more likely when a user is authenticated, that's a good time for this connection to be established. So this is the initial process of creating a socket connection. You make an HTTP request from the server that requests a protocol upgrade. And so the server, if it's equipped to handle such a request, if it's equipped to handle WebSockets, will respond with a status of 101, which means switching protocols. And then the protocol is upgraded from HTTP to a WebSocket connection. And that is when you have this open, persistent, bidirectional connection established where both the server and client can initiate communication and send messages to each other at any time. And the other end will be listening readily for those messages. This process is called a handshake, and it's friendly, as you can see. So you're probably wondering, how do I get started with WebSockets? I would recommend just jumping into one of these third-party libraries. They really do make it a lot easier to implement WebSockets. I use Socket.io, which is primarily developed for JavaScript environments, but I do believe they have versions for Python, Java, etc. But do your research, figure out which library is most suitable for you. Once you've done that, you can start building something like a simple chat app. See if you can send messages to another client and have them receive it in real time. From there, you can get a little more complicated and implement rooms. You can learn how to broadcast socket messages to an entire room, so like a group of users. And you can work on handling socket disconnections, because actually socket connections disconnect very frequently. They don't persist across browser reloads or even page navigations. So every time that the user reloads their browser, a new socket connection has to be established, and oftentimes you have to, sort out on the server who this user is that's reconnecting and implement the logic that keeps track of which users are which, even though they will frequently be changing socket connections. And of course, I recommend that you stay tuned on this channel for more videos. There will be more videos about how to actually get started with WebSockets. So I hope you've enjoyed this introduction to WebSockets, and as always, thank you for watching, and of course, happy coding. All right, folks, take care.